Hello, everyone. Good evening. Today, I'll take you through from data to policy, mining urban development patterns in Kansas City, and applied data mining analysis of big data. So, I'll take you on a journey through the data of Kansas City to understand how it's growing and evolving. We'll be using data mining to turn thousands of building permits into a clear story about urban development. So, the big question and why it matters. So my research question was, how does residential construction in investment across Kansas City and what its relationship to the new housing supply? We'll be sorting our data from obviously the Open Data KC portal. And the significance of all this is that permits are a real-time pulse of urban growth, informing policy on housing, infrastructure, and equitable development. So our central question is simple but powerful. Where is Kansas City building and what does this tell us? We used this city's own public data on building permits. This isn't just a paperwork, it's a gold mine of information that can help planners, policymakers, residents make smarter decisions about the city's future. We used our data mining toolkit. We used it's Python. That's the technology we used. So Python with pandas was used for data cleaning and skit-learning for machine learning. The challenge here was that the raw data was a bit messy, requiring conversion, cleaning, and standardization. The advanced need in this project was for city-wide analysis. We would need distributing computing like the Apache Spark to handle the scale. So to tackle this, as I said, we used Python. It was perfect for the heavy lifting of data cleaning, converting text to numbers, handling missing values, filtering for what we needed, specifically the new residential construction permits. We also identified that for a truly citywide historical analysis, more powerful distributing computing tools would be essential. Now I go straight to the method. So we're trying to find patterns with our K-means clustering. Our key analytical technique was the K-means clustering. Think of this as a smart algorithm that looks at the districts and naturally groups them based on how much they are investing and how many new housing units they are adding up. We'll let the data tell us the story rather than forcing it into categories we invented. The goal of this was automatically to group council districts based on their development profile without any preconceived labels. And what we actually clustered on was the total investment. That's the permit values versus the supplies, the dwelling units added. Now I'll go to the key findings. This is what we find. Finding number one, the algorithm reviewed 3 district development profiles. And here's what the data told us. The algorithm clearly identified 3 different Kansas cities within the city. First, we have 3 high investment, high growth districts. That's the powerhouses of new development. Then we have the 5 moderate investment districts with steady activities there. And finally, we have the 5 low investment districts that are seeing very little new constructions. This uneven landscape is the core of our finding. Findings number 2 was the investment geography. Drilling deeper, ranking of investment by district is visually confirms this concentration. A small number of districts are attracting the bulk of construction dollars. We also found strong correlation where investment is high, the number of new housing units are also high. This seems obvious, but now we can quantify them. So a clearly look at the bar graph would speak to what the data tell us. Investment is not actually evenly distributed. The top districts receive a disproportionately large share of development capital, and there is a strong correlation, as I said, that exists. More investments generally means more housing units. My finding number 3, that's our third finding, which to me is the most important, is the spatial pattern. Perhaps that's the most compelling one. As I said, when we map the clusters, we don't see a random scatter. We see clear geographical patterns. High growth districts cluster together, suggesting that factors like transportation, access, or specific zoning policies are creating development hotspots, while other areas are kind of left behind. So development is actually especially clustered. The high growth areas obviously are likely linked to existing infrastructures, policy incentives, or marketing trends. This creates a clear map of hot and cold zones for development, where the high growth see a lot of development and the low areas do not see anything at all. So, from insight to action, what is the implication for policymakers? As I said, what all this means is that it means we can move from a one size fits all policy for tailored strategic approach. In high growth areas, the city should actually focus on managing the growth responsibly. In low growth areas, the goal actually should stimulate investment in those places where investors can be able to also go in there and create more housing units and investment, putting more investments in there. This analysis provides the evidence base to make those decisions effectively and equitably. In conclusion and for future work, we've shown how data mining can turn municipal data into a powerful tool for urban insights. This isn't the end of the story. Future work could look at trends over time or incorporate data on affordability. The key takeaway is that our cities are speaking to us through data, and we just need to learn how to listen. Thank you for your time. I'm now happy to answer any questions. Thank you. All the best. Attached is my YouTube video in support of this. Sorry, attached is the PowerPoint presentation. This is actually the YouTube video. Attaches the PowerPoint presentation. All the best. Thank you. Bye.